Okay, class, picking up where we left off at, we were using a substitution method. We took the second equation and got y by itself, and then substitute what y was equal to into the first equation, which we wrote down here. And then we multiply, we had 2x, 3 times a minus 2x is a minus 6x, 3 times a minus 2 is minus 6, and we brought down our equal 6. Now we combine like terms, 2x minus 6x is a negative 4x, minus 6 equals 6. Now we will add 6 to both sides, and negative 4x is equal to 12. We divide each side by negative 4, and x equals negative 3. Now that took care of the x value. Now we want to find the y value. Now we could use any one of the two original equations or the equation that we got the variable by itself. I typically use the equation where we got the variable by itself to substitute in for x to solve for y. So we have y equals negative 2x minus 2. Y is equal to negative 2 times negative 3 minus 2. Y is equal to negative 2 times negative 3 is 6 minus 2. And y is 4. So our solution here would be negative 3, 4. And you could check this by substituting in negative 3 and 4 back into the two equations. Now, we scroll down here. Now this is one of the best situations where the equation is already set up for you. So we would substitute in negative x minus 1 for y. So we have 4x minus 3, and then we add negative x minus 1 equals 24. So we have 4x, a minus 3 times a minus x is a positive 3x. Minus 3 times minus 1 is plus 3 equals 24. 4x plus 3x is 7x, plus 3 equals 24. We will subtract 3 on both sides, and 7x is 21. We divide each side by 7, and x is 3. So now we go back to one of the two original equations, and we can substitute in 3 for x. I would suggest we go with the one that has the variable by itself. So we have y equals negative x minus 1. Y is equal to a negative 3 minus 1. Y is equal to negative 3 minus 1. And y is negative 4. So our answer here would be 3, negative 4. Now this time I'm actually going to go through and check this. So we're going to substitute. Let's take this top equation. So this is what we use to get the solution. Now we're going to go through and check. So we will have y equals negative x minus 1. We'll substitute in negative 4 for y, and then 3 for x. So we have negative 4 equals negative 3 minus 1. And we know negative 4 equals negative 4. So we know that 3 negative 4 works for the first equation. Now we need to do the second equation, which is 4x minus 3y equals 24. So now we substitute in 3 for x. So we have 4 times 3 minus 3 and negative 4 for y. 4 times 3 is 12. Negative 3 times the negative 4 is a positive 12 equals 24. So we know 12 plus 12 is 24, and that equals 24. So that means it works for both of them. So this right here is your final answer. Now we come to the next problem. Same direction, solve by the substitution method. So this time I think we should get x by itself, because if you notice x has no number in front of it. So we can add 2y to both sides, and we will have x is equal to 2y minus 3. Now we will take this value, and we will substitute this in for x in this top equation. So we have 5 times 2y minus 3 minus 4y equals 9. So this will be 10y minus 15 minus 4y equals 9. 10y minus 4y is 6y minus 15 equals 9. We add 15 on both sides, and 6y is equal to 24. Divide each side by 6, and y is 4. So now that we know what y is, we can go back and use one of these three equations. I will use this equation here, the one that has the variable by itself. So we have x is equal to 2y minus 3. X is equal to 2 times 4 minus 3. X is equal to 8 minus 3. And x is 5. So our ordered pair is 5, 4. And of course, you're free to check it. Now we have another substitution problem. Again, we will substitute in, since this has the variable by itself, we will substitute in this value for y. So we have 5x minus 2 times 3x minus 7 is equal to 8. So we have 5x, this would be minus 6x plus 14 is equal to 8. 5x minus 6x is negative x plus 14 equals 8. Subtract 14 on both sides, and negative x equals negative 6. We divide each side by negative 1, and x is 6. So now we go to this equation here and substitute in 6 for x. So we have y equals 3 times 6 minus 7. Y is equal to 18 minus 7, and y equals 11. So our ordered pair is 6, 11. And that is our final answer. Now again, we have the substitution method. Now, it doesn't matter which equation we use. Let's use the top equation this time. Let's get y by itself. So we would take this top equation. Want to get y by itself, so we will subtract x on both sides. And y will be negative x plus 10. Now we're going to take this value here and substitute this value in for y here. So we have x minus negative x plus 10 is equal to 6. Now we know when a minus in front of parentheses, it changes the sign of everything inside the parentheses. So it'd be x plus x minus 10 equals 6. So it'd be 2x minus 10 equals 6. Add 10 on both sides. 2x equals 16. Divide each side by 2. And then we will have x equals 8. Now, we need to go back and substitute into one of these three equations here. You know, I always typically use the one that has the variable by itself. So we have y is equal to negative x plus 10. Y is equal to negative 8 plus 10. Y equals negative 8 plus 10. And y is equal to 2. So our ordered pair here is 8, 2. And you can check your answer just to make sure it's correct. Now we have solved linear systems by the addition method. The substitution method is most useful if one of the given equations has an isolated variable. A third and frequently the easiest method for solving a linear system is the addition method. The addition method, like the substitution method, involves eliminating a variable and solving an equation containing only one variable. We will eliminate the variable by adding the equations. We want to obtain two equations whose sum is an equation containing only one variable. The key step is to obtain for one of the variables coefficients that differ only in sign. To do this, we may need to multiply one or both equations by some non-zero number so that the coefficients of one of the variables, either x or y, become opposites. Then when the equations are added, this variable is eliminated. Solving linear systems by addition. If necessary, rewrite both equations in the form ax plus by equals c. If necessary, multiply either equation or both equations by appropriate non-zero numbers so that the sum of the x coefficients or the sum of the y coefficients is 0. Add the equations in step 2. The sum is an equation in one variable. Solve the equation in one variable. Back substitute the value found in step 4 into either of the given equations and solve for the other variable. And 6, check the solution in both of the original equations. Now we come here. It says solve by the addition method. Now if we look here, we have 3x plus 2y is 48. 9x minus 8y equals negative 24. It doesn't matter which variable you want to get rid of. Let's say we wanted to get rid of the y's. And I'll tell you why I picked the y's. Number one, I picked the y's because they already have opposite signs. So now we look at the coefficient of y. We have a coefficient of 2 for the first equation, a coefficient of negative 8 for the second equation. So we could look at this almost like it's a fraction for the denominator. What is a common, if I was looking at this as a fraction, I would say what is the common denominator of 2 and 8, but we would say common multiple of 2 and 8. It would be 8. That would be the lowest common multiple. So to make this 2 8, we'll multiply this whole equation by 4. And since this already has an 8, we will leave the bottom equation the same. So this top equation will become 12x plus 8y is equal to 4 times 48 is 192. And we'll bring over the bottom equation. Now we will add these two equations together. 12x plus 9x is 21x. These 8y's will simplify out to 0. And it equals to 192 minus 24 is 168. We divide each side by 21. And x is 8. Now we will go through to one of these equations here and substitute in 8 for x. Let's try the bottom equation. So we have 9x minus 8y equals negative 24. So we have 9 times 8 minus 8y equals a negative 24. 9 times 8 is 72. Minus 8y equals negative 24. Subtract 72 on both sides. So we have negative 8y equals negative 96. Divide each side by negative 8. And y is equal to 12. So our final answer here will be 8, 12. And we can substitute it in and check it. Now we scroll to the next problem. Since we simplified out the y's, let's simplify out the x's this time. Now the common multiple of 4 and 2 we know is 4. But if you notice, they have the same sign. So one of these equations must be multiplied by a negative number. So since this already has a 4, we know we will only multiply this bottom equation by negative 2 here. So the top equation will stay the same. The bottom equation, negative 2 times 2x is a negative 4x. Negative 2 times a negative 3y is a positive 6y. And negative 2 times 7 is a negative 14. These x's simplify out. 5y and 6y is 11y. And 3 minus 14 is negative 11. Divide each side by 11. And y is negative 1. So we go back to one of these two original equations. We'll put in negative 1 for y. Let's try the bottom. So we have 2x minus 3y equals 7. 2x minus 3 times negative 1 equals 7. So we have 2x. Negative 3 times negative 1 is a positive 3 equals 7. Subtract 3 on both sides. And 2x is equal to 4. Divide each side by 2. And x is 2. Our ordered pair is 2, negative 1. Now we come to our next problem. Now this problem is a little different because if you notice, both variables are not on one side. So the first thing we need to do is move all the variables so that all the variables will be on one side. So we will add 2y here on both sides. So we have 7x plus 2y equals 5. Here we will add 2x on both sides. And we add 2x plus 3y is equal to 16. Typically we try and have the order of x and y, x first, y second. So we'll put these on top of each other. And now we will try and solve this like the other problem.